Good morning, students. This is KG Mishra. Again, I'm here with the new chapter for class 9th, that is gravitation. We have already completed 2 chapters with their NCERT and additional exercise. Okay. See, what is gravitation? See, the chapter is gravitation, and the first topic we are going to deal, that is also gravitation. Okay. But the question is, what is gravitation? Start writing first. The force of attraction between any two masses, the force of attraction between any two masses in this universe is called gravitation. Okay. Now see, you might have heard about different types of forces. Like see, magnetic force. Magnetic force arises due to magnetic property, magnetism. Electrostatic force, that occurs between the charges. Okay, charge, they produce their electric field, and that's why this force occurs. And when we are coming to the gravitational force, then what is that particle due to which this force arises, or what is that quantity due to which this force arises? This force arises due to the mass. Okay, so I should say mass is the source of this force. Okay, whenever you find two masses, they are always attracting. Okay, even you will also attracting each other. The walls are attracting you. Okay, and the tree which is outside, that is also attracting you. Even the buffalo and the cows. Okay, and that is goats and the snakes outside. Okay, if they are there, they all are attracting you, and you are attracting them also. The fan is attracting you, and the light is attracting you. Okay, not this much only, everything around us, okay, attracting each other. Even the cow dung is also attracting us, and we are attracting it. Okay, so that is due to the force that is called gravitation, because they have got the mass. Okay. What is mass? Mass is the material content in the body. Okay, because they are having something in themselves. That's why that is what mass. So this attraction is due to the mass, and that attraction is called gravitation. Okay. Now, next is universal gravitational law. Okay, so universal gravitational law. Universal Do you know who has given this law? It was Sir Isaac Newton who has given this law. He is also known as father of modern science. Okay, you might have heard that story, very famous story. He was sitting under the apple tree, and an apple fall down, and he just started thinking, why it has come down, not gone up. So he has given this law. Okay, written that, just write the statement. It states that the force of attraction between any two masses in this universe is directly proportional to the product of masses, and inversely proportional to the square of separation between them, and inversely proportional to the square of separation between them. Okay, now see what we got from this law. First we got, if suppose two masses are there, this is one mass, this is another mass, this mass is m1 and this mass is suppose m2, and the separation between them is r. So what happens? The force which is going to act between them, that is proportional to product of the masses. This is the first thing we got. And what is the second thing we got? Second thing we got, it is inversely proportional to square of distance between them or square of separation between them. Okay. Okay, write it down. But I will like to ask a question to you. Suppose one day, no, before making chapati, no, some we might have seen at home. No, what is done? The flour is mixed with water to make a paste, and then chapati is made from that. Suppose your mother has given a big ball of that paste of flour, okay, and its mass is suppose 10 kg, okay, and she has asked you to divide into two parts so that the gravitational force between them is maximum, okay. So how you will divide them? Just think. Oh, so tell you. Okay. Suppose see it is 10 kg. So how can you divide it? You can divide it 9 kg and 1 kg. The product is how much? 9 only. The products must be maximum. If you are dividing like 8 and 2, 8 to 16, it is more than that. See here it is 9. Here product is 16. More than that. Okay. 7 into 3, it is 21. Okay. Then 6 into 4, 24, even more. 5 into 5, it is 25. Again 4 into 6, again same thing will repeat, 4 into 6. So inverse of this 24, okay, then 21, then 16, then 19. Okay, so when it is maximum, when you are dividing it half, so what you need to do, you must divide it half. Okay, 5 kg, 5 kg, and then you will get the maximum force. Got it? Now let's come back to this expression. After this you write, from equations 1 and 2 we get, right, from equations 1 and 2 we get written, okay, what we get, let's see, F is proportional to m1 m2 for r square. That's what we have got. Now whenever there is a proportionality sign, what we do, we remove this proportionality sign and place equality sign. For that we require a constant. Okay, here also the story is same. F is equals to capital G m1 m2 upon r square. Okay, that's what we get. Now what is capital G? Capital G is known as universal gravitational constant. Okay, now note it down, where capital G is known as universal gravitational constant. Written. See here. What is the value of capital? 6.67 into 10 is the power minus 11. Okay. Newton meter square per kg square. That is the unit. You should remember this value. Okay. Because you will get it to use in numericals. So you must remember this value. How we got the unit? See, you want the unit of this, so you take all other things this side. So for this it is Newton. This also will get multiplied with this. So meter square, kg into kg upon kg square. Okay, that's the unit of that. And why it is called universal gravitational constant? Because its value is constant throughout the universe. That's why it is called universal gravitational constant. Got it? So its name itself tells its characteristics. Okay. Now the question arises, why we study this universal law of gravitation? What is the use of this? See, let's go different to understand different things, okay, around us. Like see, we know that no, Earth revolves around the sun. So why Earth revolves around the sun? What is the reason? See, my dear children, I have told you, if something wants to rotate in a circular path, okay, or move in a circular path, then what it is required? There's a center, suppose. So it requires a centripetal force. It requires a force towards the center. Okay. Now, if the sun is at the center, and suppose here it is Earth, so sun is attracting the Earth towards center. So Earth is getting centripetal force, and that's why it is revolving around the sun. Okay. So first point you can write. Okay. Write the first point. Okay. uh, Importance of universal law of gravitation. At the first point, the rotation of earth around the sun. In bracket you can write the attraction between sun and earth provides necessary centripetal force to the earth for rotation. Okay. Second point, rotation of the moon around the earth. Rotation of moon around the earth. Again you can write in bracket the attraction between earth and moon gives the necessary centripetal force to the moon for motion in a circular path. Okay, for motion in a circular path. Okay. Okay, now third one, all the things are held with the earth. Why? Due to gravitation force only. Okay, so right, all the things are held with the earth due to gravitation force. Now fourth, the tides, high tides and low tides. Okay, the tides take place due to the gravitational force between water and the moon. High tide and low tide takes place due to gravitational force between water and moon. Okay, written. Fifth point, rivers flow due to gravitational force. You might be wondering why. You might have seen, see, rivers, where they originate, actually they originate from the mountains, no, and they are at height up places. Okay, and they come down. Why? Because of gravitation only. The water is being pulled down, so that's why water is running, okay, flowing in the rivers. That is due to gravitational force. Okay, even lots of things you will get. Okay, many examples you will get. Okay, this universe is intact due to gravitational force. The planets and all heavenly bodies are arranged properly due to the gravitational force of each other only. Okay, so these are the lots of examples are there. Okay, now see, next topic is gravity. Okay, first start writing, then I will explain you. Okay, start writing. The force of gravitation between a heavenly body and any other body. A heavenly body and any other body is called gravity of that heavenly body. Is called gravity of that heavenly body. Okay. For example, gravity of earth, comma, gravity of moon. Okay, so it is gravitation only, but if one body is a heavenly body and another is any other body, okay, then we call it gravity. Okay, so gravity is nothing but it is gravitation. Okay, now suppose we are talking about the earth, so what will the gravity for it? Obviously, see, gravity of the earth is how much? It is F is equals to capital G. Capital M is the mass of the earth. Okay, suppose this is the earth and this is the center of the earth. Okay, here an object is placed, small object of mass small m. Mass of the earth is capital M. Okay, and this distance is how much? Radius of the earth is capital R, and this distance is very small, so we can neglect this small distance. We can say that distance between the center of this object to the center of this earth. Okay, the distance from the center of the earth to center of this object is almost equal to radius of the earth. Okay, so what we can write? Gm m by r square. Okay, this is the force of gravity of earth. Okay, because we are going to study about gravity of earth only. Okay, in this. So this is the expression for gravity. Just note it down. Now next topic is acceleration. Due to gravity. Now see, its name itself indicates everything. What is it? It is acceleration. And why this acceleration is produced? Due to force of gravity. So suppose I am going to release this chalk will fall, but it will not fall with uniform velocity. It will form with constant acceleration, and that acceleration is called acceleration due to gravity. Okay, and this has got a symbol, no? Small g. Okay, so it is acceleration. People call it gravity. No, it's not gravity actually. It is acceleration due to gravity. Gravity means it is force, but it is acceleration. How force and acceleration may be same? It can never be same, no? So don't get confused while talking. Be precise about your words, okay? Especially when you're talking about the science subject. Not only science, you must take care of all the subjects, okay? Because you cannot utter wrong date when talking about the history, okay? Wrong place when you're talking about geography. So accuracy is required because the students are supposed to be most accurate people. Okay. See here, acceleration due to gravity is g. How to find this? We know that when there is acceleration, no, then what will happen? Force is equals to mass into acceleration. That we know very well. Mass of the body is m, and it is dropped. So what will happen? Its acceleration is g. So what is the force of gravity? It is F. Clear? So we can mark it equation number 1. Okay. But what we know? F is equals to gm small m by r square. That we know. We know it or not? This is the force of gravity. No. Written? Okay. Now you write from equations 1 and 2. From equations 1 and 2. Written? Okay. What will get? Both are values of F. We can equate them. So mg is equals to capital G, capital M, small m upon r square. Small m can be cancelled out. Okay. Done? Okay. So what we are getting? Finally we are getting small g is equals to capital G, capital M upon r square. This is the expression for acceleration due to gravity. Now you tell me, in the expression for acceleration due to gravity, what are the things which are appearing? It is universal gravitational constant. It is not going to change throughout the universe. Okay. Radius of the earth, it is also not going to change. Mass of the earth, it is also not going to change. Okay. So that means acceleration due to gravity remains constant. Either you are dropping an elephant or you are dropping an ant. Okay. For both, the acceleration will be same due to gravity. When acceleration will be same, obviously, what will happen? People will ask you a question. Suppose you are dropping a ant and elephant, okay? So which is going from the same height, okay? So which is going to fall on the earth first? So people come up with the answer. Oh, sir, elephant will fall first, okay? Because it is heavier, no? It is larger, no? No, it's not the case. Both touches the ground together. Why? Because see, this tells all the story. Because acceleration with which they are falling has nothing to do with their mass. Okay, they are heavier or lighter, doesn't matter. Okay, sometimes you will find if you are dropping a page, okay, paper, and you are dropping, suppose, a pen or a stone. What you find from the same height? You find a stone reaching to the ground first. The paper takes time. Why? Because it keeps on floating due to the air. Okay, because air resistance is also playing its role. But if air is not there, if you do the same thing in vacuum, you will find both are touching the ground at the same time. Okay, so don't carry it out by misconceptions. Your concept must be clear. Got it? Now, what is the unit for this acceleration due to gravity? It is acceleration. No? It is a member of family of acceleration. So its unit will be also unit of acceleration. What is unit of acceleration? Obviously it is meter per second square. Okay, its unit is meter per second square. Okay, in that formula we put the value of capital G, that is 6.67 10 to the power minus 11. If we put the value of mass of the earth, that is 6 into 10 to the power 24 kg. Okay, we put the value of radius of the earth, that is 6.4 into 10 to the power 6, and square of that. What result we get? We get 9.8 meter per second square. Okay, that's what we get. See, in numericals you will always taking 9.8. Okay, unless it is given 10 in the question. It has been observed that children try to take 10, okay, for convenience in calculation, but don't do that. Okay, you must do this, that you must take 10 only when it is given in the question, otherwise take 9.8. Got it? Clear? Okay, so that is it. Next heading is free fall. Okay, so what do you mean by free fall? Start writing first. When a body is falling under the influence of only gravitational force of earth, comma, then it is known as free fall. Full stop. Now you just tell me, suppose I'm going to drop this chalk, so is it free fall? No. Why? Because gravitational force of earth is acting, okay, that's okay, but at the same time air resistance is also acting, so that force must not be there. Only gravitational force of earth should be there. Okay, only gravity of earth should be there, no other force must be acting. Only then we can say that yes, it is free fall. That means when you are dropping any object in vacuum, then it is called free fall, because there no other force is acting. Clear? Okay, now when a body is falling freely, what happens? This is earth, this is the object, it is going to fall. So it is exerting force in which direction? It is attracting, so acceleration is G is really acting in the same direction. Okay, when you are throwing an object, so your velocity is in this direction. Okay, it is initial velocity in this direction, but acceleration is acting in which direction? This direction. Both directions are opposite, and remember, direction of motion is always taken positive. So what will be the sign of this acceleration? It will be negative. Why? Because it is opposite to the direction of motion. What about the case of falling? In case of falling, it will be positive. Why? Because direction of motion and direction of acceleration both are same, so it will be positive. Acceleration will be positive. Okay, so we can write the equations of motion. Okay, you have already studied the equations of motion, 3 equations of motion that I am going to tell you. So in case of free fall, equations of motion, we will have 2 parts. One, upward motion. Upward motion, what you will get? G is negative, remember. So first is V is equals to U minus GT. It was U plus AT, but A is minus G because it is going up and acceleration is downward. So minus GT. So that's what we will get. Second was what? It was S. But here it's not covering distance, it is covering height. So instead of S, we will have H. H is equals to UT plus half AT square. So instead of plus, we will get minus G and T square as it is. Okay. Why? Because for upward motion, we know A is equals to minus G and S is equals to H. Okay. And last one is V square is equals to U square plus 2AS minus 2GH. Okay. Those are the equations of motion. Okay. So V square is equals to U square minus 2GH. Clear? Here it is H is equals to UT minus half GT square. Okay, clear? So these are the equations for upward motion. Okay. Now, in case of downward motion, what will get written as out of this? Okay. B part. Downward motion. See, acceleration is equals to displacement plus g, and s is equals to h. That's what we have to take here. So v is equals to u plus gt. Next one is s is equals to no s, h. H is equals to ut plus half gt square. Okay, and next one is v square is equals to u square plus 2gh. Okay, it was minus 2gh in that one. In this one it is plus 2gh. Okay, this is for downward motion. Got it? Okay. See, I'm going to give you some more formulas. Okay, just see the condition when it is going to be used. Suppose a body is there, okay, at a height h. This height h, a body is there. Okay, this is the body. What is its mass? We don't require to know. Okay, we are not interested in that. And we are just going to release it. When it is released, then its initial velocity is how much? It is 0. Okay. Now, the question is that how much time it will take to hit the ground. First thing, we want to find out the time. Second thing, we want to find out the velocity. Okay. Now, my dear children, when a body is released from height h, then the velocity with which it hits the ground is given by v is equals to root 2gh. Okay, 2 is number known to you, g is known to you, h only h is given. Okay, you can find out very easily. You require only h to find the velocity. With what velocity it is hitting the ground. Okay. Second thing, time you want. Okay, root 2h upon g. Again, see, for finding time also you require only height. So whenever anyone asks you question, okay, and ask you question that a body was released from height of 100 meter, so how much time will it take to hit the ground? You can find out very easily. You know the value of g, you know that it is 2 is known, okay, and put here 100 and calculate and find the root and get the time. At the same time, no, you are asked to find the velocity, you can use this formula. Okay, understood? Very nice. Okay. Okay, student, that's all for this video. Okay, next video I will come with some more concepts and numericals also. Okay, because we have done formulas in this part. Till then, take care, keep on studying. Okay, bye bye.